Hi everybody, Grandad here. And what am I up to today? Well, today I'm going to do some more of my chemistry, and today we're dealing with sodium hydroxide. Now I'm looking at the Merit book here, which shows you the experiments that they do with that kit I bought, and in it, one of them is sodium hydroxide. Now, sodium hydroxide is a very strong alkali, and it's used in all sorts of processes. So today I thought we'd try and do a few little experiments using the sodium hydroxide. Now you can buy it already made up in drain cleaners and stuff like that, but I thought because it's in this chemistry book, I thought I'd try and make some. Now the two ingredients you need to doing this are sodium carbonate, which is actually in this bottle, sodium carbonate, and I haven't got a lot left, and slaked lime. Now I'll put a little bit, I've got some distilled water here in a jar, and I'll put pretty much all of my sodium carbonate, I haven't got a lot left, into the slaked lime, into the distilled water there. Give it a little stir up. Now unfortunately it doesn't really tell you how much you have to use of these chemicals, but I've used all I've got, so I don't know. And I haven't got a lot of slaked lime left either. So I'll pour all that in. Now this doesn't make a terribly strong solution. As you can understand, it's not pure, as you buy with drain cleaners and if you bought sodium hydroxide clear. But hopefully it's good enough, strong enough for us to use it for our experiments. Now, one of the first things it tells you to do is to get a little bit of this in a test tube, and it tells you to filter it. Now I haven't filtered it because it takes too long filtering, so I'll put it in as it is, but you should in theory filter it. And I have got some more here in a bottle, which is hopefully my backup if something goes wrong with this experiment. That's my backup solution. Now I'm going to test it with a little bit of our indicator water that we made in a previous episode. Now this white liquid there, I add the pink indicator, and straight away it's turned to a muddy brown colour. I hope you can see that on camera. Now, this isn't the first time I've made this video. I did it before and I made a bit of a mess of it. Now I'm actually going to put that video up, and I'm going to call it the video of mistakes, because I wanted to show that sometimes when you're doing chemistry you make mistakes. And I can think of a mistake I've already made before I start. I forgot to put my safety gear on, which I'm always saying that you should put your safety gear on, and of course I've forgotten this time, so that's another mistake I've made, but I've remembered in time, so I'm putting it on now. Again, I'm not dealing with anything particularly dangerous, but in the interest of safety I'll put my gloves and stuff on. So that little test of that sodium hydroxide has turned brown in that there, which I hope means that it's an alkali. Now the very first test we do this sodium hydroxide in this experimental book I got here, this little book of experiments, is one which I had a total fail on my first video. So if you watch that you'll see me failing with that, but I think I know what went wrong. My sodium hydroxide wasn't quite strong enough, or it wasn't pure enough or whatever, and so it went wrong. So I've got a backup now, so I'm hoping this time it will work. Now what it involves is mixing up a little solution in my test tube here and I need a little bit of distilled water. That's probably enough. I'll pour out some more just in case I need some. It's always best to use distilled water if you can get hold of it, because it means it hasn't got any other chemicals mixed in with it. So there we are, I've got my distilled water. Now what I'm going to mix with that is some copper sulphate, which is a sort of a pale bluey green substance. And I'll put some of that in. If I can find my little spoon, there it is. I'll put some of that in. It's quite tricky spooning this stuff up, but I'll try and get some in there. A little bit more. Right, so I've got some copper sulphate in there now. If I give that a shake, hopefully to mix it up, we end up with a pale green, pale bluey green liquid. But it's not very dense, but it's sort of a pale green colour. Now what I'm going to do to that is add a little bit. Let me just check my instructions here to make sure I am doing it right. No, have I turned over too many pages? Yes, I have. Turned over too many pages with my instructions here. Now then, add some sodium hydroxide to some dilute copper sulphate, which I've got here in the tube. So now I'm going to add my mixture, which I've just prepared, and this is quite an interesting. I'm hoping this is going to work better this time, because if you look, you can see that now I've got two different colours in the test tube. The one at the bottom is the pale green like it started with, and the top one is really blue, a really lovely blue colour. I can add a little bit more of my sodium hydroxide, and it's bubbling a little bit, and I'm going to shake it up and mix it up. And of course it's jumping out of the bottle a little bit, which is why you need to wear gloves and protective clothing. So that's if I can get that to mix up a little bit better with puffing a bit of air into it. I want that to mix up well. Now the next thing it tells you to do is to add some heat, warm it up a bit. Now this is where my last experiment failed, and I hope you can see alright that I've got my little burner here in the background. I hope I've moved the camera to a better position than I did before so you can actually see what's going on. But I've got my burner here, and I'll just put it on. Just gently. Here we are. I thought I was going to have another fail with my burner for a moment. Now you can't see the flames very good, but I can hear it roaring, so I know it's working. Now I'm just going to hold this test tube by its little holder and diddle it around in the flames a little bit and watch while it gets hot. Now then, if I've been successful this time, as I say, with chemistry it doesn't always work, but even by your mistakes you can learn something. I'm hoping that we'll see a chemical change. Now, I failed on the last one, as I said, but I tried it again afterwards, and it actually worked with the same solution. I just added a little stronger sodium hydroxide, and it worked. So I'm hoping that I've mixed a stronger one this time, and that I will be successful in the experiment. because I wouldn't want you to think that maybe it didn't work and therefore it doesn't work. It does work, it's just that I didn't do it right. And that's a useful lesson to learn. If you don't succeed at something, don't give up on it. You may just have made a mistake. So try again and alter the chemicals around a little bit, and you may find that you did do it right. It's just that it wasn't quite... Now I can feel it bumping a little bit in my hand, so I know that it's getting really hot now. And I can already see, I think, some black coming round in my chest tube. I hope I can anyway. Oh, it's boiling up a little bit. You definitely see some black happening there. Now it doesn't turn completely black. Now this happened before. Now it has got a little bit of black in the bottom, but as I said, I've got a backup here, which is another little bit of sodium hydroxide, and it may be that I haven't filtered that and it may not have mixed completely. So I've got a little bit stronger one here, and I'll put that in, and now I can see, and that's what was wrong. The sodium hydroxide that I've made, at this moment, it may not be dissolved completely because it's cold. If I'd have heated it up, maybe that would have worked. But this hydroxide that I made in here, for some reason, isn't quite strong enough. And so it didn't quite work properly. Now this time, I've added some more. As you say, I can feel it bumping, as I call it. When you boil things up, they bump. And I can feel the bumping. And my liquid in the test tube, I've got to be quite careful I don't overboil it. But now that, as you can see, has turned completely black. Now that's what was supposed to happen before, but it looks as if my hydroxide wasn't quite strong enough. Now it doesn't mean to say I didn't make hydroxide. We've proved that I did by putting the litmus powder in, but it may not be quite strong enough to make this reaction work. But by adding a little bit more, which is a little bit stronger, it's turned it black. Now that now is copper oxide. Now if I leave that on the side for a while, I'll turn out my burner, because I don't need that for a second. I'll show you in this file, which is copper oxide. If you let it settles to the bottom, and you end up with a clear liquid, and the black copper oxide settles to the bottom, and you can take off the top layer of water and keep the oxide in the bottom. Now that's useful because I'm going to do some more experiments using copper oxide to turn it into back into copper metal, which hopefully will be another video, but we won't do that today. But we just wanted to try that. Now let's have a look what the next experiment is on here. Now it says here that you add a little bit of sodium hydroxide to a little bit of magnesium sulfate. And I've got some magnesium sulfate here, and I'll add it in one of these smaller test tubes. And I'll just put a little bit in to this smaller test tube. I'll leave that one in there now, hopefully to cool off. It's got my oxide in. I'll put this one here, and I'll put in here a little bit of magnesium sulfate. Just check again I've got the right thing. Magnesium sulfate. I'll put a little bit in, a little bit more in. Get a few spoonfuls of it. So I'm making a reasonably good solution. There we go. So a little bit in there. And now I'm going to add to that some of my hydroxide. Now I won't use the hydroxide that I mixed because I have a feeling that it's not terribly strong. And I want to get a good reaction with this, but it should work with that same stuff, but I'll use this out of here, which is a little bit stronger. Now I'm going to put that in. Now unfortunately, the powder that I put in was white, and it appears that the chemical reaction which we get there is white as well. Now, I don't know whether heating that up will make any difference to it. We'll just try. Why not? We'll just turn on our burner again and light it. And we'll just try heating this up a little bit, because those crystals really haven't melted. So I'll just try it, heating it up a little bit, and see if we get any change. Now it's starting to bump almost straight away, because it's quite a strong little burner. I should have a Bunsen burner, but I haven't got one. So I'm using this little camping stove. And it boils things up pretty quick, so I have to just be careful. There we go, it's bubbling a bit too much now. Now, I don't know whether this this particular experiment has worked very well. I mean, I assume it has, because we put all the ingredients there. But, so in theory, I should have now made magnesium hydroxide, because the chemicals have changed places, but they both look as if the crystals have looked different, but now I've made a different chemical. So I'll put that in my little tray there. So I hope that that was a success. Now the next one is quite an interesting one, and it takes a little time, so I've got my little burner tray here and a little cup. And what I'm going to do is put a little bit of distilled water in here and put it on the burner. Now it says put, I don't know whether I need to put so much water in. Let's tip some of that water away. I have a feeling I need more water, but now I can put some of my hydroxide in. Now I've put quite a lot in there, because it does say place some sodium hydroxide solution in a porcelain dish. I haven't got one, but I put a metal dish. Now it says add some fat, and it says lard will do. Now, the last experiment I used, I didn't have any lard, but I've since acquired some. So I'll put the lard in now. Now again, it doesn't tell you how much. It just says put some, a spoonful. I don't know. So I may be putting too much, I may not be putting enough, I don't know. But anyway, I put that in. And it also says have a spoonful of salt. So I'll put my spoon now down here, and I'll put some salt in there. But apparently you don't put the salt in straight away. It says boil gently, and then add a spoonful of salt, and allow to cool. Now I'll get my little burner going again. That's going. I'll turn it down a little bit. I'm hoping that's going to cook. Now it'll take a little while, so while that's cooking, we'll try another experiment, which it says, which I didn't do before, but I'll try it this time, and that is mixing our hydroxide with alum. Now in this bag here I've got some alum. That's probably too much. A little bit too much, I think. Some alum crystals. I'll just keep an eye on my little pot here. Put some alum crystals in there, and I'm going to add which is actually aluminium sulfate. I'm going to add Ooh, blimey. Fumes from that are pretty strong. In fact, I'll turn that down a little bit. That's boiled enough, I think. I'll put my salt in. I'll stir it up. And see if anything at all happens in there. Right. There's one experiment going on. Now this one, I've got my crystals in here of alum and my hydroxide. Now not a great deal has happened. The alum has melted, but there's not a dramatic change. But according to my information here, by putting the alum, it's pouring part is aluminum sulphate, it says a white participant should be obtained in the usual way. But then it says continue adding, and it turns white again. Now I may well have done that wrong. I may have put too much in to start with, because it says only add a little bit. But it is white. It's sort of white. Now I'll add a little bit more in as it says, and it should turn clear again. I don't know whether it will. Yes, I would say that has worked. The alum, which was sort of milky and cloudy, has now turned back to completely clear again. So that experiment has worked because we've got a clear liquid. Now I'll put that into that little dish there and leave it for a while we go on with another one. Now it says here, place a small piece of zinc in the solution of hydroxide and we should get bubbles of gas coming off. Now I tried this before and it didn't work terribly well, but off camera while I was fiddling around, I actually mixed some in this test tube. So I've already done the experiment, and I think I've got some more bits of aluminium here. I might have to take my gloves off for this because they're tiny and I can't pick them up. We'll get that back out again. So I've got a little bit of sodium hydroxide in here. I'll add a little bit more just to strengthen it up a little bit. And in here I've got some little tiny balls of aluminium. And I'm placing those in the test tube with the hydroxide. Now this takes a little while to work, so I don't know whether we'll be able to come back to it. But I put it in before and I noticed after a few minutes the aluminium started to bubble and fizz a little bit. So I'm hoping that that's what's going to happen with this. Now I don't know whether we'll be still filming by the time this actually happens because it takes a little while, but you'll just have to take my word for it that when I put aluminium in the hydroxide solution, it does dissolve it. Now another experiment I did was with cotton. Now we'll try it again with cotton because I don't seem to have the right piece of the right test tube there. So I'll put a little bit of our hydroxide into the test tube. And this time I'll add what I believe to be a bit of wool. Now I've already done this and it does work, but whether it'll work in the time for this video I don't know. But I've got a little bit of wool here and I'm dipping it in to the hydroxide in this test tube. Now I'm going to leave that for a little while and hopefully come back to it. So that's that was the next experiment. Now apparently if you use wool, if it is wool, it will dissolve. But if you put cotton in, it won't dissolve. So it's a test for cotton, or whether you've got cotton or whether you've got wool. Because if it doesn't dissolve, then you've got cotton, and if it does dissolve, you've got wool. Now as I say, it takes a little while for that to work, and it took a little while the last time I did it. So I don't want to make this video go on too long. So it may well be that we don't get the result before we're at the end of the... Now then, if we look in this first one, we can see something's happening. This is the one that I put the aluminium in. And now you can see that it's strongly bubbling. Those little pellets of... it's going so fast, it's getting really hot. Boy, that's hot. Pick that up with my tweezers. Now that's hydrogen gas, I believe, being given off at the top there in those bubbles. And in theory you should be able to light them. I don't know whether they will. Hydrogen goes off with a bit of a pop, and it did. So there's hydrogen gas being produced there. My little lighter is not behaving itself. So that there it goes. I don't know whether you saw that, but the bubbles coming off my hydroxide there is definitely hydrogen, because when they come into contact with the air, I've got another little bit of tiny bit of aluminium foil here, which I'll just try to quickly roll up, and I'll drop that in the solution. Might get a little bit more solution, but that was quite interesting. Not only did I produce a lot of heat, so hot that I couldn't hold on to that test tube, but the bubbling was actually hydrogen, which I was able to light with this little lighter. So that proves that the experiments in here do work, although you do have to fiddle around with them a little bit. So we've showed all that now. Now hopefully my little can here is cooled down enough that I can get hold of it. And so my final little experiment, which I was trying to do, has hopefully worked. Now the last time I did it I used butter because I didn't have any lard, but I've tried it again. Now it says that if you've done it right, you should have a skin forming on the top of this liquid in here. Now there's definitely something forming on there, but at the moment, and again I don't know whether the quantities were wrong or whether there was some problem with it, I don't know, but there's definitely a skin forming on this dish. Now I can't show it very well and it's still quite warm, but there's definitely, I'll try and show it, I don't know whether it will, but if you look in there, there's definitely a skin forming on the top of that liquid. And I'm hoping you can see it, but you may not be able to. Now it does say that if you can get hold of that skin, it gets thick enough and you can get hold of it, you can form it into a little block. And the reason you can do that is because this process actually makes soap. Now we know that when we made this hydroxide it had a soapy feel to it, but apparently by adding the hydroxide to lard, and again I don't know whether I put enough in, I mean I just put a spoonful in, I didn't know how much, in fact I thought I'd put too much, but it doesn't appear that it was. And then the salt, I don't know whether I added enough salt. I added quite a bit of salt. It said a spoonful, but I don't know. Put a little bit more in just in case. I mean, you never know with these things. You might need a